All right, welcome back. This is the second lesson on simplifying polynomial expressions. Now remember, technically we are working with rational expression. Remember, rational expression is more general, and I want to remind you from the last video this was covered. Every polynomial is a rational expression. Okay, if rational expressions represents the big set. Okay, every polynomial is a rational expression, but it is not the case that every rational expression is a polynomial. Polynomials are a specific type of rational expression. Now, just to reinforce the last lesson, remember that rational expressions are polynomials divided by what? Polynomials. Okay? Or polynomial divided by polynomial. I guess singular is fine. Polynomial divided by polynomials. So how do we differentiate between the two? Remember that rational expression means there is a variable in the denominator. Or I should say, what makes something a rational expression but not a polynomial? If there is a variable in the denominator, then we are just in rational expression, but we are not polynomial. Okay, so let's look. 3xy plus 2z minus 8 over 2x. Okay, since there is a variable, notice, on top we have what? On top we have a trinomial. And on the bottom we have a monomial. We look at the bottom. Since there is a variable in the denominator, we call this what? We call this a rational expression. Okay, this is a rational expression. That's as specific as we can be. However, if I write 3xy plus 2z minus 8 over 2, okay, question, is this a rational expression? Yes, everything that we're dealing with today is a rational expression. Notice we have a trinomial divided by a monomial. However, since the denominator does not have a variable x, we can be more specific and name this by the numerator. Since there is no variable in the denominator, this is a specific type of rational expression called what? A polynomial. So we're just going to name this by the numerator. We can be more specific. If we call this a rational expression, that is true, but it's too general. We can be more specific and call this what? Trinomial. So reminding you, if there is no variable in the denominator, we can name it just by the numerator and call this trinomial. Why? Because the 2 divides every term. So we're looking at 3 over 2 xy plus 2 divided by 2. 2 divided by 2 is 1, so we get 1z. And 8 divided by 2 is 4, so we get minus 4. Okay, so we're looking at a trinomial. So reminding you, if there's a variable in the denominator, the most specific that we can be is rational expression. If there is no variable in the denominator, you name it by the numerator and call this a trinomial, and this falls in the specific realm of polynomials. Now, today we're talking about polynomial expressions, but more generally we're talking about rational expression. All right, but the lesson is called Simplifying Polynomials. Most of what we're dealing with today is just polynomial, or specifically polynomial. Now, we are going to, again, simplify, reminding you simplify means, okay, simplify means to what? Add, subtract, multiply, and what? Divide. Okay, add, subtract, multiply, and divide. And today we are going to focus just on multiplication division. Remember that simplify does not mean to make simple. Simplify means to add, subtract, multiply, and divide. And I will show you most of the time when you simplify something, it gets smaller. But I will show you expressions in this class that when you simplify them, they start very small and they get very, very big. So simplify does not mean to make simple. Simplify means to add, subtract, multiply, and divide. Now, starting with multiplication division. Okay, so when I say multiplication, I'm also talking about division. Remember, there are only two operations in math, multiplication and addition. If I say something is an addition rule, it also applies to subtraction. Also, if I say something is a multiplication rule, it also applies to division because multiplication and division are the same thing. Now, multiplication rules are called laws of exponents. Okay, again, if you have not watched the first video, make sure you watch that first. Laws of exponents, and we are talking about what types of rules? Multiplication rules. Okay, remember that laws of exponents refer to multiplication only. Okay, now, you can star this, all right? And we're looking at the first law of exponents. It says x squared multiplied by x to the third. Okay, when we have 2 x's multiplied by 3 more x's, we add the exponents and get x to the 5th. Why? Well, because x squared means x times x, and x to the 3rd means x times x times x. Since we have 2 x's multiplied by 3 more x's, we get 5 x's multiplied together. Okay, are we adding the exponents? Yes. But if I ask you today, what are we doing? Are we adding or are we multiplying? You should answer, we are multiplying. Why? Okay, we are not adding. We are counting the number of times in which we did what? We are counting the number of times in which we multiplied. So when I say with my mouth adding the exponents, what I mean is that we are counting the number of times that we multiplied. All right? So remember, adding exponents, we are not actually adding today. We are just multiplying. We are counting the number of times in which we multiplied x. So we had 2 x's multiplied by 3 more x's gave a total of 5 x's multiplied together. Or I say when the bases match, x matches x, add the exponents. Now, what if we have x to the 5th divided by x squared? Okay, so if we multiply, we add the exponents. If we divide, we subtract the exponents. 5 minus 2 gives 3, so we get x to the 3rd. To show you why, we're looking at what? 5 x's, x times x times x times x times x, over 2 x's, x times x. And when we have multiplication, we can cancel 2 x's with 2 x's, leaving how many x's? We're left with 3 x's where? On top, because there were more x's on top. Now, so we have addition of exponents, subtraction of exponents. We also have multiplication of exponents. X squared to the 3rd power. When we have power of power, we multiply the exponents, we get x to the 6th. Why? Because x squared cubed means x squared multiplied by x squared multiplied by x squared. We have 2 x's, 2 more x's, 2 more x's, making a total of what? 6 x's multiplied together. Do you want to add 2 3 times or multiply? It's faster to multiply to get 6. Now, we have addition of exponents, subtraction of exponents, multiplication of exponents. What's missing? We're missing division of exponents. And reminding you, division of exponents is not covered today, but it's covered soon. Division of exponents refers to square root. In elementary school, you learned that 6 divided by 3 was 2. This is elementary school division. Now we're looking at high school division, which is square root. This is a fancy division symbol. We're looking at square root of 16 is what? Square root of 16, you were always told, is 4. This is fancy division symbol. Fancy division. Dividing what? We are dividing the exponent. We will talk about this soon. But today, we are not covering division, just addition, subtraction, and multiplication of exponents. Now, number 1 on this sheet that I've given you, the practice sheet 6-1, number 1 on the practice sheet says n to the 5th multiplied by n squared. Okay, so I expect that you pause the video. It would be best if you pause the video and knock out numbers 1, 2, 3, and 4. I will write them on the board. By y cubed multiplied by y squared. I have to write these big so that you can see them. Number 3, t to the 9th multiplied by t to the negative 8th. And number 4, x to the negative 4th multiplied by x to the negative 4th multiplied by x to the 4th. All right, now, for each one of these problems, we see that the bases match. We have n matching n, and we are multiplying. Since the bases match, you add the exponents. You see this is what? N times n times n times n times n multiplied, or 5 n's multiplied by what? 2 more n's, giving a total of what? 5 n's and 2 more n's give a total of 7 n's multiplied together. So we are just simply adding the exponents. Here, 7 y's times 3 more y's times 2 more y's. We add the exponent. 7 plus 3 is 10 plus 2 gives y to the 12th. Okay, number 3. Again, even if we have negative exponents, we still add. 9 plus negative 8 is 1, so we get t to the 1st power. Do we have to write the 1? No, we just write this as t. Now, before we go on, I want to remind you, negative exponents. What do negative exponents mean? Okay, so I'm just going to write this, and I'm going to have to erase it again so we have space. Negative exponents. Okay, negative exponents mean, I said in the last video, negative exponents mean to move from numerator to denominator. So if we have t to the negative 8th, t to the negative 8th power, this means move it where? From the numerator to the denominator, and we're going to have 1 over t to the positive 8th. So notice, t to the negative 8th moves from the numerator to the denominator, and notice when it moves, nothing is left on top. And when I say nothing with my mouth, Nothing with my mouth means a 1. Okay, so t to the negative 8 moves to the bottom. We change the sign of exponent from negative to positive. And what's left on top? Nothing. So we write a 1. Okay, so 1 over t to the 8. Now, what if I write x here? What if I write 1 over x to the negative 2? Remember that we cannot have, the rules of simplify say that we cannot have rules. Okay, rules. There are unwritten rules for simplify. Rules say no negative exponents. No negative exponents in final answer. No negative exponents in final answer. So we have to convert negative exponents to positive exponents in order not to lose points. So x to the negative 2 means move it where? Move it to the top, so we get what? X to the positive 2, and what's left on the bottom? Nothing is left on the bottom. We have a 1. Okay, so x squared over 1 is just written as x squared. Now, what if I write 3 to the negative 2? I ask students, is this a positive or negative value? Remember, negative exponents have nothing to do with positive or negative values. 3 to the negative 2 means move it where? Move it to the bottom, so we get 1 over 3 squared, which is 1 over 9. Now, what if I write 3 to the negative 1 power? 3 to the negative 1 power, again, means move it where? Move it from the numerator to the denominator, make the exponent positive. So we're going to say 1 over 3 to the first power, which is 1/3. Now, another way to think of negative exponents mean change multiplication to division, or vice versa. Okay, so negative exponents mean change multiplication to division, or vice versa. Okay? Now, so we say 12 multiplied by 3 to the negative 1. Okay? We can also think of negative exponents as changing multiplication to division, so we end up with 12 divided by 3 to the positive 1, or 12 divided by 3 is 4. Okay, so change multiplication to division is another way of thinking about negative exponents. Now, all right, so looking here, we're looking at t to the negative 8th. I want you to rewrite this. Can we write this as t to the 9th over 1 multiplied, and I want you to convert the negative exponent to positive. So we're going to move it where? Move it to the denominator. So we get 1 over t to the positive 8, which is what? Multiply on top, we get t to the 9th on top over what? 1 times t to the 8th, t to the 8th on the bottom, and you see what? We see 9 t's. I'm just going to write this out. T times t times t times t times t. So we have 9 of these things. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 t's over what? 8 t's. So 9 t's over 8 t's. Remember, we can just do it like this. Cancel 8 with 9. If we cancel 8 t's with 9 t's, we're left with what? Notice, you can see it here. 8 t's cancel with 8 t's, leaving how many t's left over? I should say 8 t's cancel with 9 t's, leaving how many t's left over? 1 t. Where? On top. So it's simple concept of subtraction. 9 subtract 8 gives 1, so we have an extra t left on top. That's another way to think of it. Now, so our answer is what? Answer is t over 1, which is just written as t. Now, again, we add our exponents. Negative 4 plus negative 4 gives what? Negative 8 plus 4 gives x to the negative 4 power. Okay, now, remember, this is not a final answer because rules of exponents say that we cannot have no negative exponents in final answers. So x to the negative 4th has to be moved where? Moved to the denominator. Okay, so we're going to have what? Nothing left on top, so we have a 1 on top over what? X to the negative 4 becomes x to the positive 4. Okay, 1 over x to the 4th. Now, I want you to rewrite this problem, the original problem, as here. X to the negative 4, rewrite this as 1 over, moving it to the denominator. We get 1 over x to the 4th, multiplied by what? 1 over x to the negative 4 moves where? To the bottom. 1 over x to the 4th. Remember, move it and make the exponent positive, or change it from negative to positive. Multiplied by what? X to the 4th stays. Why does it stay? Because the exponent is positive. So we have x to the 4th over what? 1. Now multiply on top. 1 times x to the 4th gives x to the 4th over x to the 4th times x to the 4th is x to the 8th times 1. We're adding the exponents. Okay, we get x to the 8th, and now cancel. Notice you have x times x times x times x, or 4x's on top. You have x times x times x times x, 8x's on the bottom. Okay, so if we cancel 4x's with 4x's, we're left with how many x's? Or I should say it like this. Here you see it. 4x's cancel with 8x's, leaving how many x's? Well, 4 extra x's are left over. What are we doing? We are subtracting. 8 minus 4 gives 4, but where do we have more x's? You have to pay attention. We have more x's on the bottom, so we get what? 4 x's on the bottom, and what's left on top? Nothing. And when I say nothing right now, I mean what? A 1. So we have 1 over x to the 4th. This is our answer. Now, so you've seen it two different ways. I want you to see this as canceling, and I also want you to see this as adding your exponents and moving the negative exponent from the top to the bottom. Now, next problem. Numbers 5, 6, 7, and 8 is what we're looking at now. Let's see. Number 5 says quantity 2f to the 4th to the 6th power. Number 6 says negative 2, b to the negative 2 power, c to the 3rd, all this to the 3rd power. Okay, so here we have a case of exponents on the outside of parentheses. And I want to remind you, what is negative 2? What is negative 2 quantity squared? Do we square the negative and the 2? Yes. Okay, so we're squaring both. Remember that exponents, we say, distribute over what operation? Multiplication. You're seeing negative 2 as negative separated from 2, or negative 1 multiplied by 2. We don't write the 1, we just read negative as negative 1. Since there's multiplication here, the exponent distributes over both. So we're squaring the negative and the 2. We end up with negative 1 times 2 times negative 1 times 2, or we read this as negative 2 times negative 2, which is what? Negative 1 times negative 1 is 1, 2 times 2 is 4, so we get positive 4. What if I write negative 2 squared? Since there are no parentheses, the exponent just affects the 2, so we end up with negative 2 times 2, or we're just squaring the 2, not the negative. So negative 2 times 2, we multiply the 2 twice, or I'm sorry, 2 times 2 is 4, multiplied by the extra negative 1 is negative 4. So you see the difference. This is positive 4, this is negative 4. Okay, so there's a big difference with parentheses or no parentheses. Now, looking at the problem given, are there parentheses? Yes, there are parentheses. So does the 6th power affect the 2 and the f to the 4th? Yes, it does. So we take the 6th power of both. Remember, the exponents distribute over what? They distribute over multiplication. So we're taking 2 to the 6th, okay, which means what? 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2. It is not 12. It is 2 multiplied by itself 6 times. 2 times 2 is what? 4. 2 times 2 is what? 4, and 2 times 2 is 4. So we can pair them up. 4 times 4 is 16, times 4 gives 64. So we end up with 64, and now f to the 4th to the 6th. What happens when we have power of power? You're looking at what? Here. You're looking at f to the 4th, multiplied by 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 f to the 4th. Do you want to write this 6 times? No, this is old business. We don't want to do this. Instead, we look at our rule. Okay, we don't want to write x squared. When we have x squared cubed, we don't want to write x squared, x squared, x squared. Instead, we just do what? When we have power of power, we multiply the exponents. So we take 6 times 4 and get what? F to the 24th power. So just simply multiply your exponents. Look at number 6. So I want you to pause the video and attempt number 6 on your own. Okay, now coming back, are we cubing the negative? Yes. Are we cubing the 2? Yes. Are we cubing the b to the... Excuse me. Cubing b to the negative 2 power? Yes. Cubing c quick? Yes. We're cubing everything inside parentheses. So start with the negative 1. Treating the negative 1 as separate from the 2. Cubing negative 1 means what? Negative 1 times negative 1 times negative 1 gives what? Gives negative 1. Okay, so we're going to write this as a negative. Remember, we don't write the negative 1, we just write negative representing negative 1. Now, cube the 2. If we cube the 2, we get what? 2 times 2 times 2, which is what? This is 8, so we get 4 times 2 is 8, so we get negative 8. Now, cube the b to the negative 2 power. Cubing b to the negative 2, remember, power of power we multiply. So multiply the 3 times the negative 2, we get b to the negative 6 power. Now multiply again, 3 times 3 gives c to the 9th power. Now, is this an acceptable final answer? No. Remember, rules say no negative exponents in the final answer. So what do we have to do? We have to get rid of negative exponents. Question, does b have a negative exponent? Yes. b has a negative exponent of -6. Negative exponents mean move from top to bottom or vice versa. Now, is the negative in front of the 8 an exponent? No, this is a -1. This is different. Okay, so negative in front of the 8 means negative number. Let me show you. Question. Is -8, does this mean move it to the bottom? Is -8 equal to 1 over 8? No, this is wrong. This is completely wrong. Negative number does not mean move from top to bottom. However, what if I write 8 to the -1 power? Notice here we have a negative exponent. Okay, nothing negative out front, we have negative exponent. This does not mean negative number. This means move from numerator to denominator, so we move it where? We move it to the bottom and we get 1 over 8 to the +1. Okay, so we have 1/8. So is there a difference between -8 and 8 to the -1 power? Yes. -8 is a negative number. 8 to the -1 power is a positive number. It is the number +1/8. Move it to the denominator and make the exponent positive. So in this case, does the -8 move? Does the -8 move? No. But does the b to the -6 move? Yes. Where does it move? It moves what? It moves to the bottom. So we're going to have -8 c to the 9th over the b to the -6 moves to the bottom, becomes b to the +6. So when you move it, just make the exponent positive or change its sign from negative to positive. This is our answer. Number 7. Number 7, we have 4d squared. Let me write it bigger. 4d squared t to the 5th v to the -4th multiplied by -5d t to the -3rd v to the -1. Now my question is, up top, do you see an exponent on the outside of parentheses? Yes, then we multiply the exponents. Here you have an exponent on the outside of parentheses, so you multiply the exponents. Question, do we have an exponent on the outside of parentheses? No. So we're not multiplying exponents here. Notice, we have d squared multiplied by d. We are just simply adding the exponents. If we have x squared multiplied by x cubed, since the bases match, we add the exponents. 2x's multiplied by 3 more x's gives 5x's. 2d's multiplied by 1 more d gives 3d's. Okay, so we're going to first do our numbers. 4 multiplied by -5 gives -20. Okay, now d squared times d, or 2d's multiplied by 1 more d, gives d to the 3rd power. 5t's multiplied by t to the -3rd, we add the exponents. 5 plus -3 gives, the signs are opposite, adding actually becomes subtraction. 5 minus 3 gives 2. Take the sign of the larger, since it's positive, we get what? T to the +2 power. Now, v to the -4th, v to the -1, add the exponents. -4 plus -1. Since the signs are the same, you add, we get v to the -5th. Now, question, is this a final answer? No. Why? Because we cannot have negative exponents in the final answer. So v to the -5th, v to the -5th, this is a negative exponent, it has to move where? It has to move to the bottom. So if we move it to the bottom, we get what? -20. Remember, -20 is different. This is a negative number. That is not a negative exponent. -20 is different than 20 to the -1 power. Okay, 20 to the -1 power is negative exponent. However, -20 is not a negative exponent. This is a negative number. It stays put. Okay, so we have -20, d to the 3rd, t to the 2nd power, over the v to the -5th moves to the bottom, becomes v to the +5. All right, now, next question. Number 8. Okay, leaving that down there for a minute. Number 8 says 8u multiplied by 2z to the 3rd power. Now question, does the exponent affect the 8? No. Does the exponent affect the u? No. The exponent affects everything inside parentheses. So are we cubing the 2 and the z? Yes. Okay, so we have what? 8u is unaffected. We have 8u multiplied by cube the 2. Cubing 2 is not 6. Cubing 2 means what? 2 times 2 times 2, which is what? 8. Cube the z, we get z to the 3rd. So we cube everything. Now 8 times 8 is what? 64. And just glue this together. Remember, multiplication means glue. Just glue it all together and put your variables in alphabetical order. U comes before Z. So we have UZ to the third. This is our final answer. Okay, so we are simplified at this point. Number 9 on the sheet. Let's see. Number 9 says, now we're getting into canceling. Number 9 says 12 m to the 8th y to the 6th over negative 9 m y to the 4th. Okay, now in this case, notice we have a negative in front of the 9. Is the negative connected to the 9? No, the negative is separate. So this is, again, different from negative exponent, but it floats around. Negative represents negative 1. It can float around, so you can put it out front or you can put it up top. It's generally the convention to put this in the numerator. So we're going to take this negative, move it to the numerator in a moment. Let's first start by canceling. What number divides 9 and 12? Hopefully you say 3. So 9 divided by 3, 9 divided by 3 is 3. Write this. 12 divided by 3 is 4. Let's write the results. Okay, so I want you to put the negative on the top with the 4. So we're going to have negative 4. Notice, this is different from negative exponent. When it moves, or it floats around. It doesn't really, I guess, don't think of it as moving negative exponent. It floats around. It floats to the top. It's still negative. Okay, now 3 on the bottom. And now cancel. 1m cancels with 8 m's, leaving how many m's? It's a concept of subtraction. 1m cancels with 8 m's, leaving 7 m's where? 7 m's on the top. 4 y's cancel with 6 y's, leaving how many y's? Hopefully you say there are more y's on top, so we have 2 extra y's left on top, or y squared on top. So our final answer is negative 4m to the 7th y squared over 3. This is your answer. Okay, number 10. Erase everything so we have space. Number 10 says negative 6n 5x cubed. I don't like the way the book writes this problem. 18 n x to the 7th. Let's just clear up this confusion. Do we see any addition in the problem? No. By the way, what are we looking at here as far as nomenclature? Is this a polynomial or rational expression? Okay, so if we look here, are there variables in the denominator? Yes. So what are we technically looking at? Variable in the denominator means the most specific we can be is what? Rational expression. So technically we're looking at rational expression. Now, go ahead and just multiply. There's no addition. Multiply on top. Negative 6 times 5 gives a negative 30. And we have nx to the third, keeping our variables in alphabetical order, over 18 nx to the 7th. And now we just simply cancel. What number divides 18 and 30? Pick the largest number. Hopefully you can see that 6 divides both numbers. 18 divided by 6 is 3. Negative 30 divided by 6, well, hold on. Ignore the negative. Okay, let's ignore the negative. Just think 30. 30 divided by 6 is what? 5. So let's rewrite this. The negative is just hanging around. So we have negative 5 over what? 3. Now cancel. 1n cancels with 1n. What's left if we cancel our n's out? Well, there's a 1 left and a 1 left. Do we write the 1's? No. I say with my mouth, nothing is left. Remember, 2 over 2. If we cancel the 2's, you agree that 2 over 2 is 1. If we cancel the 2's, we're not left with 0 and 0. So if I say nothing, I'm not talking about 0. If you cancel, what are you left with? You're left with what? A 1 and a 1. Okay, now, so we have n's canceling. So we're left with 1 and 1, which we don't write. 3x's cancel with 7x's, leaving how many x's? Hopefully you say 4x's on the bottom, because we have 4 extra x's on the bottom. So we have negative 5 over 3x to the 4th. This is our final answer. And number 11. Okay, number 11. This is negative 27x to the 3rd multiplied by negative x to the 7th over 16x to the 4th. Now, just simply multiply, Negative 27 multiplied by negative 1, we can treat this negative as separate from this x to the 7th. Here, is the exponent affecting the negative? No. Let me take the parentheses away. Okay, is the exponent affecting the negative? No. The exponent is just affecting the x. However, and the parentheses are written like this, however, what if the 7 were on the outside of the parentheses? Does the 7 affect the negative? Yes. Does the 7 affect the x? Yes. However, this 7 is not written on the outside of parentheses. It's written on the inside, so it's just affecting the x. So something to keep note or take note of. The parentheses aren't even necessary, really, other than to separate this negative so that we don't read this as subtraction. Go ahead and multiply. Negative 27 multiplied by negative 1 gives positive 27. The negatives cancel out, become positive. And what do we have here? X to the third times x to the seventh. If the bases match, we add the exponents. X squared times x cubed, we get x to the fifth. So 3x's multiplied by 7 more x's is x to the 10th. Or 10x's multiplied together over 16x to the fourth. Now, if we try to cancel 16 with 27, there is no number that divides 16 and 27, so we're stuck. However, 4x's cancel with 10x's, leaving how many x's? It's a matter of subtraction. 10 minus 4 is 6, so we get x to the 6th, or 27x to the 6th over what? 16. Okay, next. Number 12. Number 12 says 2 over 3r squared t cubed z to the 6th, all this to the second power. Okay, what do we do here? Does the exponent affect everything inside parentheses? Yes. Reminding you, law of exponent. If I write on the board, well, I'm just going to put it here. X over y here. This is our last problem today. XY quantities squared. Does the exponent affect the x and the y? Yes, it does. Because, well, we end up with what? X squared, y squared. Because exponents, we say, distribute over multiplication. Now, why is this the case? Well, because if I write xy quantity squared, this is what? This is equal to xy multiplied by xy, which is x squared, y squared. Now, so do exponents distribute over multiplication? Yes. So therefore, should not, if I say something applies to multiplication, should it not also apply to addition? Yes. So what if I say x over y squared? Does the exponent affect the x and the y? Yes. We square both. We get x squared over what? Y squared. Why is this the case? Well, let me write it. X over y squared means what? X over y multiplied by x over y, which is what? X squared over what? Y squared. So you see x times x, y times y. So if we have a fraction, does the exponent affect everything inside parentheses? Or I should say if we have parentheses, does the exponent affect everything inside parentheses? Yes, even if we have a fraction. So exponents distribute over division. So we're squaring everything. We're squaring the 2. Remember, 2 squared is 2 times 2, or what? 2 times 2, or 4, over square the 3. 3 squared is 3 times 3, which is what? 9. Square the r squared. Now, if we have power of power, if we have exponents on the outside of parentheses affecting other exponents, we multiply. Okay, so 2 times 2 gives r to the what? R to the 4th. Power of power, we're multiplying the exponents, we get what? T to the 6th. Multiplying the exponents, power of power, we get what? Z to the 12th. And we are done.